Okay, so -10, -5 is like right here. Okay, 1/4 of a movement, -1/4 of a movement, we're flipping down. So our end behaviors are going to be pointing down. Our vertical movement is now multiplied by 1/4. And so things are getting a little tricky. So moving 1 down 1 would become over 1 down 1/4. And so instead of making it harder on myself, I'm going to work smarter instead of harder. And so I'm going to think about, okay, well, my vertical movements are 1, 2, 4, 3, 9. And I'm going to try and think of vertical movements that are multiples of 4. So then that way, when I take the fourth of that vertical movement, it results in numbers that are nice and easy and round. So for instance, the horizontal movement of over 1, which results in a vertical movement of now down 1/4 of a number, which is very little, I know that instead if I move over 2, I would be able to go down 1, right? Because then it would normally be that you'd go down 4. Well, it's normally that you'd go up 4, but taking 1/4 of that, now it becomes 1. And now since it's negative, it's down. We're graduating, we're doing it, we're making big steps. So instead of our normal movement of right 2, up 4, we're now going to go right 2, down 1, because we took that up 4 and multiplied it by -1/4. I'm going to go over 2, down 1. And I know, because I know that parabolas are symmetric across our axis of symmetry, that there's also going to be a point over here. This point is -8, -6. That's a point, or that's a point towards having this labeled. Is now I don't have to be like, oh wait, 2, 4, 6, that it's labeled, and I can just know it. Okay. Now I'm not going to do my 3, 9 movement of right 3, up 9, which would transfer over to 9 divided by 4 isn't nice, so I don't want to do it. So instead of doing my movement of 3, I'm going to do my movement of 4, because if I move 4 with your normal parabola, going back to kind of this idea of what I was showing you here, you would do 4 and then 16, which is like, I don't know, maybe not that high, but pretty high, right? And 16 is divisible by 4. So I would do my movement of 4 to the right, 1, 2, 3, 4, and then take that vertical movement of 16 and multiply it by -1/4, which makes it become -4. So I go down 1, 2, 3, 4. Oh, common mistake. Going over 4 means 1, 2, right? 2, 4, and then down 2, 4. Yes. Right? Yes. We'll talk about this in a sec. -6, -9, and then -14, -9. We are not going to have an x-intercept, which means that our x-intercept would be a complex number, right? Remember that when we get complex answers, so imaginary answers, it's because our actual parabola does not cross that x-axis. But we will have a y-intercept. We always have a y-intercept. Y-intercepts are when your x value is 0. So imagine as all of these guys going to 0, and you're left with -30. So that's what your y-intercept would be, and that'd be 26, 28, and then 30 would be like right down here. So all good things to keep in mind. I'm going to go ahead and draw my best parabola to go with it. Now, as I said in our last notes, this shortcut is really great for quick, easy graphing. You don't need to like make a set of points. The vertex form is like really all you need. And then it's just kind of remembering that this is how quadratics behave. And that's really important when we're graphing it. But it's also really important to double check your work with this shortcut because it's really easy to make a mistake. As you saw, I made multiple mistakes in this, which is okay. We just need to have a solid double check. So with all of these, I would recommend that we double check. I'm going to plug in -6 for this guy. -1/4 times -6 squared minus 5 times -6 minus 30. Go ahead and tell me real quick with this double check, what do I hope is going to be the value that I get back? If I plug in -6 and everything works out fine and that point is correct, what y value am I hoping that I'll get back? I'm hoping that I'll get back a -9, right? If I plug in -6 into here and I did everything correctly over here, if I get a -9 back, then this point is on the line, on the curve. Okay, so -6 squared is 36. That becomes plus 30 minus 30 is really nice. Those guys cancel out. -1/4 of 36 is -9. And that is the value that I was looking for. Everything turned out well. I made a few mistakes, but I was able to bounce back. I might come back here and label my y-axis 0, -30, sorry, my y-intercept, because that's what my instructions told me. And that's it. That's done. There's one more thing that I want to talk to you about. And the thing that I want to talk to you about is our axis of symmetry. We've talked about it a bunch already, but realize that your axis of symmetry always goes through your vertex, and it's always a vertical line, and that the equation of a vertical line is x equals a number. It's always x equals a number because that's how we write equations of vertical lines. X equals and then some sort of number. That number is the x value of our vertex. And we've now created this formula for our vertex that works every single time. Abstract algebra gives us formulas. Every formula that you have came from some sort of abstract algebra process that was able to formalize a mathematical process without using any numbers. And when we don't use numbers and instead use variables instead, you're now proving that this works not just for that number in that situation, you're now proving that this works for every single number that you could possibly think of to plug in here. Any number this would work with. And that's where formulas come from. So our axis of symmetry is going to be x equals to the x value of our vertex. So I would like for us to now go back, because it says label the vertex and the axis of symmetry. So we're going to go back and label the axis of symmetry. So our axis of symmetry splits that parabola straight down the middle, and that straight down the middle is going to be right here. It goes through the vertex. So your axis of symmetry is this guy. The equation of your axis of symmetry is x equals 3. You can even say axis of symmetry, AOS. Let's see it again. Your axis of symmetry goes through your vertex. It is right here. Tell me on your own, what is the equation of your axis of symmetry? This equation is x equals -2. Last one, tell me what it is. Your equation of this axis of symmetry is x equals -10. So it's just this axis that you could like rotate it around, that you could reflect it around, that you could fold it across, and it still reflects onto itself. Okay. One last thing that I wanted to talk about is writing equations of quadratics. So we're given two pieces of information here. We're given the vertex and a point that is on this equation. And so we can use our vertex form of a parabola to kind of write out your basic idea. The basic idea of a quadratic in vertex form is this. And so if we have something like the vertex, we can plug those values in for what we know within the vertex form. So y equals a times x minus, and that's going to be a +2 squared plus k is +1. Now we've almost got an equation of a quadratic. We're just missing one thing. What is the thing that we are missing? We are missing the variable a. We are missing the number that's supposed to go there. Realize that all of our quadratic equations always have a y and an x. It just doesn't have an a. So how we find a is that we now plug in this point. So plugging in this point, 2.5 for y, 3 for x, we can now solve for a. Go ahead and tell me what you get for a. The value that we get for a is 1.5. So we can go ahead and let me show you. So putting it all together, 2.5 equals 3 minus 2 is 1, 1 squared is 1, so that's a plus 1, subtracting 1 is 1.5. 1.5 equals a. Our equation then would be y equals 1.5 times x minus 2 squared plus 1. All right, good job today.